Hey everyone, welcome back to another exciting geometry lesson. Today we are diving into one of the most simplest yet most powerful circle theorems, the tangent radius theorems, which says the tangent to a circle is perpendicular to the radius at the point of contact. Let's break it down, prove it, and see how it's used in real problems, all in a simple way. Let's go. First, what is a tangent? A tangent is a straight line that touches the circle at exactly one point. It does not cut through. That point is called the point of contact. For example, in our diagram, this line PT is a tangent because it touches the circle only at a single point, and our line OT is the radius of the circle. Our tangent radius theorem, tangent perpendicular to radius. The theorem says the radius drawn to the point of contact is perpendicular to the tangent. It means that our radius OT and tangent PT, they are perpendicular to each other. That means they meet at 90 degrees. And it can be written in symbol like this. OT is perpendicular to PT. Let us quickly prove this. It's very logical. Now, before we actually prove the theorem, let us consider this. Let us say we have a straight line, and let us say we have a point here. Let us draw a line from this point to this line. Let us name this point P, and let us name this line AB. Now let us consider this little diagram. This is our point P, this is our line AB, and we connect point P with our line AB with different lines. This is the first one, this is the second one, third one, fourth one, fifth one. And by inspection, you can agree with me that the shortest distance between this point and this straight line is this line. So the shortest distance between a point and a straight line is actually perpendicular to one another. It means that this straight line and this line, they meet at 90 degrees. So let us now continue with our proof. A circle with center O with tangent PT at point of contact T is given to us, and we want to prove that OT is perpendicular to PT. Let us pick a point on the tangent and name the point Q. Let us say we pick this point on our tangent, we name it Q. Let us connect O and Q together. Now let us name this point at which the line touches the circle. Let us name it R. You will agree with me that line OQ equal to OR plus RQ, and also OT equal to OR because they are radii of a circle. Since OR equal to OT, so we can say that OQ is greater than OT. OQ is greater than OT. Now also, if we pick another point from our tangent PQ and connect it, you will see that the line will also be longer than our line OT. So what I'm saying here is that the shortest line that connects our tangent is line OT, and the shortest distance from a point to a line is always perpendicular. So we can say OT is perpendicular to PT, and that the tangent radius theorem proved. Let us consider this example. If the distance from the center O to a point P outside the circle is 13 centimeter and the radius OT is 5 centimeter, find the length of the tangent PT. Let us represent it diagrammatically. Let us draw our circle with center O. Let us say this is our center O, and let us name a point P outside the circle. Let us say we have a point here which is P, and outside the circle. And the question also say the radius OT is 5 centimeter. Let us name this place T, and let us join here and this place together. This is 5 centimeter. And the question said that we find the length of the tangent, and the tangent is a line that touches the circle at a point. So we are going to connect this point and this together. So this point is T. The question says the distance from the center O to a point P outside the circle is 13 centimeter. This is our center O, this is our point P. That means a distance from this point to this point is 13 centimeter. Since radius and tangent meet at 90 degree, so we can say this angle is 90 degree. Now we can apply Pythagoras theorem, and Pythagoras theorem says pt square plus ot square equal to op square. Our ot is 5 centimeter and our op is 30 centimeter. Let us substitute it into this equation. pt square plus 5 square equal to 13 square, and pt square plus our 5 square is 25 equal to 169. Our 13 square is 169. Let us collect the like time by moving 25 to the other side, and this positive sign will change to negative. So pt square equal to 169 minus 25. pt square equal to 144. Let us square root both sides. Square root pt square equal to square root 144. This one we cancel this one. pt equal to square root 144. and square root of 144 is 12. So PT equal to 12 centimeter. That is the length of our PT. To wrap it up, a tangent touches a circle at only one point. The radius drawn to that point is always perpendicular to tangent. This forms a right angle, perfect for applying Pythagoras theorem. Easy, right? Don't forget to check the next circle theorem in our playlist. And if you learned something today, smash that like button, subscribe, and keep learning with Teacher B. Thank you.